today, Craig Allen is going to continue to examine some of these climate change and fire-related issues. And he's going to talk to us about a research program that he's been carrying out at and around Bandelier Wilderness. And he's been kind of elusive about the details of his talk, but his title, 1,000 Years of Landscape Change in the Bandelier Wilderness, will have to suffice. I can, however, tell you a bit more about his background and credentials. Craig Allen is a research ecologist with the U.S. Geological Survey and is the station leader of the Jemez Mountains Field Station based at Bandelier National Monument. And he's worked in the Jemez Mountains since 1986. He's one of the principal investigators of the USGS Western Mountain Initiative, an integration of research programs that study global change in mountain ecosystems of the western U.S. As I mentioned last week, I attended a lecture that Craig gave a couple of years ago in which he talked about the ways in which land use practices had contributed to soil erosion in Bandelier. And his experiments to devise simple ways to stop erosion and stabilize the soil had much in it for archaeologists. It was an excellent presentation, and I anticipate that his talk today will be just as good. So thanks for being with us today, Craig, and thanks very much for your patience while I got organized.
All right, no worries. So, and thank you for the invitation. And elusive, is that how you would define it, huh? And by the way, if people have questions along the way, feel free to unmute your phone, I guess, and ask. I have a fair number of slides, and I'll move through them otherwise quickly enough. But sometimes it's better to stop when it's up on the screen and the thought is fresh. So I don't mind that. So we'll talk about landscape change in this particular landscape of Bandelier. Oops, that's not what I want. What I want is, you may have to bear with me about navigating this thing at first till I get it working. So I just want, so the title slide, just adding that there's a lot of people have contributed to this, to ideas and some of the work that's presented here. Just a map, the Jemez Mountains, Bandelier National Monument is an old Park Service unit from 1916 established to protect cultural resources, and it's located in the southeast flank of the Jemez Mountains, and that's where the red arrow is pointing to there, sort of at the south end of the Rockies, the margins of the Colorado Plateau and Desert Basin Range. Zooming in on the Jemez, you can see it's a big volcanic landmass with a central caldera that's about 15 miles across, which is called the Weisse caldera. Bandelier is outlined in the yellow. And by the way, if it seems likely within hours to days that there will be a new Park Service unit. There's a 90,000 acre national preserve called the Weisse Caldera National Preserve, which encompasses that caldera. Let's see if I can make this little pointer work. This is the caldera, and there is a unit. It touches Bandelier in the northwest corner, but anyway, that will be. It looks like it's part of the Defense Appropriations Bill, and it looks like it probably will pass. There's been an effort to make a Park Service unit there since the late 1800s. So anyway, it's a little bit exciting here in this landscape. The landscape involved here ranges from elevations up to 11,000 feet here along the rim of the caldera, down to just a little over 5,000 feet, where this is the Rio Grande crossing across from north to south. And so Bandelier has that whole elevational transect. We're going to focus on these lower elevation mesa tops, which are dominated by pinon and juniper trees, a woodland system. Let me get back to the clicker. So here's zooming into a vegetation map of the park and the main part of Bandelier, and it's these orange mesa tops that are this this woodland vegetation. And this was the primary settlement zone and agricultural zone for ancestral Puebloan people, which are the cultural resources that Bandelier primarily was established for. This is what that area looks like from an airplane over the Rio Grande at the bottom of the field of view, looking back to the west over the mesas. I took this about, 20 some years ago. And we're going to focus in particular, this is a block diagram showing that elevational gradient and vegetation gradient. And we're going to focus on a 1 hectare watershed for part of this, called the Friolita watershed, which is at the upper boundary of that woodland type, where it interfaces the bottom edge of the Ponderosa Pine forest type, which is a much taller, pine. So this is zooming into that. And actually, I'll just back up and say just a small bit more that I've been working here continuously since the fall of '86, but I actually did my master's thesis research here earlier than that. So this coming year will be the 34th year in a row that I've been doing field work here in the Jemez, in and around Bandelier. It's been really a great privilege to be able to be in a place so long. I'm one of the 100 or so ex-Park Service scientists that in 1993, the biological, ecological scientists in the Park Service were transferred over to a short-lived agency called the National Biological Survey. But by '95, we ended up in USGS as part of, which is why there are a large number of biologists and ecologists in the USGS. But I've been working here, based here at the park this whole time, co-located with land managers in this particular way of trying to support conducting research, but doing it in a way to try to be supportive of land managers, not just Park Service land managers, but more broadly in the area. And in the '80s, I did both my master's and PhD studying various aspects of landscape change. And so many of the studies I'm reporting on here really evolved organically, I guess, out of that work from the beginning. So, and from the beginning, my perspective, my training was as a geographer early on, and then as an ecologist. But I've always viewed, humans and nature, these have always been interactive. We're linked, increasingly so, especially, I guess, with the theme of your talks this fall. In the Anthropocene, it's pretty clear human influence is natural. Doesn't mean much without people on this planet anymore. As ecologists, it's been painful for ecologists to get to that point in the last 30 years, but they're pretty much there, I think. So anyway, here's this watershed. The ridge line is here, and that's the top of the watershed. This is a 2.5 acres Friolita watershed, so-called because there's a 100-room archaeological site, classic Pueblo period, from the 1400s to the mid-1500s here, just above it. And in '93, we began quite a bit of work trying to understand runoff and erosion processes here, which we'll talk about a little bit. Erosion was a big issue at Bandelier, identified concurrently, well, it's actually historically was identified from the 30s on in various little documents you could see in the park. And in the 70s, feral burrows were considered to be the cause. And the Park Service, after the first natural resource research done, was trying to understand what was causing the erosion and basically implicating the burrows to justify, in the end, shooting them. In the 80s, when I started working here, it was clear there was an immense amount of erosion in these woodlands, these so-called PJ woodlands, pinyon juniper woodlands. And at the same time, there was a very large archaeological survey effort underway, led by Bob Powers, with many Park Service archaeologists involved. That was a decade in length. And they similarly were observing the impact of erosion on cultural resources. And so from that point forward, there was this linked thread from both the cultural and the natural resource perspective at Bandelier about we need to better understand what's going on with history of erosion, the magnitude of it. you could see that huge areas were basically desertified. This shouldn't be a desert. These are places with 14 to 16 inches of precip annually on average, highly variable through time, but there's huge areas that look like this in the heart of the wilderness. And by the way, so Bandelier is about 33,000 acres, and the majority of it, 2/3 of it or so, is congressionally designated wilderness, and essentially all of this pinyon juniper woodland landscape is in the designated wilderness. The soils are old. They primarily formed during the last ice age under completely different vegetation types on these mesas. Again, this is sort of the showcase arc site, Joni, down near the visitor center in Frijoles Canyon, but it's actually rather atypical of the archaeological sites in Vandalur. Most of them are on the upland mesa top surfaces. The perennial stream in the background was the big attraction here. Of course, you folks all know this, but it's important to recognize these people didn't go away. The descendants of the people who lived in Bandelier are for sure in direct lineage with the folks from what we call San Ildefonso Pueblo and Cochiti Pueblo. Bandelier was on the straddles the historic boundary between these two groups, who actually represent different language groups, but the ethnographic history, their oral histories, and the archaeological record are consistent. That basically, for those of you who have been here, the Frijoles Canyon was essentially the dividing line between the Carey-speaking people to the south, Cochiti Pueblo, and the Tewa folks to the north, and San Ildefonso. This is Taos Pueblo, modern Pueblo. So Little Big Bandelier actually has about 3,000, well actually it is literally right at 3,000 archaeological sites that have been surveyed to date. Pretty much everything except some of the really steep terrain has been inventoried by this point. But it has site densities that essentially equal those of any Park Service unit, including places like Chaco and Mesa Verde. And this is the woodland zone in roughly circled in green. This is an outlying unit of the park. That's actually spatially in the correct location, called Sankui. But you see that the high density of sites, and this is where people were living and working and farming for many centuries. When the Archaeological Survey was starting, the big survey, there in the 80s, after their first field season, we had a sit-down meeting, and they were asking if there was anything else that was worth collecting at the sites in terms of site data. And we sort of shared notes about the magnitude of erosion, so they started to collect erosion data. So the map you see on the left is from the last few years of the survey of the sites where they did collect erosion impact data. And the red sites are the sites that were being affected by erosion of one sort or another, and the green ones were the ones that were not. And the main point here is just that the vast majority, well over 90% of the ARC sites, particularly down in the woodland, were being damaged in one way or another by erosion processes. Primarily sheet erosion, but significant levels of sheet erosion. There's some pedestal building stones there. In that Friolito watershed, we had all kinds of sediment traps. We literally just this year, so for 20 years, we were running this runoff and erosion work. In this field, in the photo here, you can see this is a 1 cubic meter. It's just a wooden kind of half box sunk into the ground that captures the runoff and the sediment. And we, when we installed that for, I think, 4 years, we sieved the sediment coming out of this and similar sediment traps. Up here in the top are some of the over 1,000 artifacts that one rainstorm event, this June 29, 95 event, put more than 1,000 artifacts into this sediment trap from one thunderstorm, draining 1/4 of an acre, 1/10 of a hectare. So, I mean, this is a big part of what the archaeological or cultural resource issue with erosion was, is that it was literally smearing the archaeological record across the landscape in a really profound way. So one question is we could see that this is how the landscape was behaving. We were measuring the rates of soil erosion at that point in time, but maybe it had always been like that. Was there something new? Was there something that Park Service management needed to be concerned with? So a couple different ways to approach that. I've done an immense amount of work with dendrochronologists, mostly folks from the tree ring lab. In this case, this is Peter Brown, who has his own little tree ring lab out of Fort Collins, Colorado. In that watershed, yeah, and you can, of course, precisely date to the year. We we dated every live and dead tree in that watershed. The junipers are not precisely datable, so those we've actually had to estimate by size age regression. The tree ring dating pattern or their cross dating doesn't work on that particular species, the dominant there. But what we see here are the timelines of the logs, the dead logs that Peter Brown and we sampled basically every scrap of dead wood in that 2.5-acre piece of hill slope. And so these are the timelines. This is calendar years here on the left, so back to 1600. The bark date is designated by a little vertical bar at the end of the line of the timeline for that tree. So, you know, these would be the inner dates. These would be the last dates. Two different species, the small pine, Pinon, Pinus edulis, the large pine, Ponderosa pine. And this little gray shaded zone is the 1950s drought. And this is, you see this big mortality pulse. Most of that dead wood we were looking at that time was from the 1950s drought event, which was the last severe drought before the current drought we've been in. We've been in drought since the late 90s here in this region, driven, presumably, it's thought at this point, these decadal scale droughts are driven by decadal scale sloshing of the Pacific Ocean. There's a phenomenon called the Pacific Decadal Oscillation that basically drives the frequency of El Nino versus La Nina events. And El Nino episodes when the eastern Pacific is warm brings wet weather to us. Well, wet winters. The jet stream comes farther south in El Nino conditions, and the winter storm tracks cross over us. During La Nina conditions, the jet is farther north and the winter storm tracks miss us, and we can have almost no precip in some winters. The 50s, we can see with tree ring reconstructions going back for 2,000 years that on the order of a 30-year oscillation, we oscillate in and out of these big, these dry and wet periods. So about twice a century, these happen. The 50s was the last severe drought episode, and at this locality, it killed essentially all the Ponderosa pine on that site that had been alive. More on that in a minute. So because we dated, those were just the deadwood on the landscape, but we also cored all the live pinon trees, and there were just literally just 3 live ponderosas available in and adjoining that watershed. So we're able to actually show you in map form what this landscape looked like through time, back to 1600 when the earliest trees started. So I'm going to go through a series of these maps that look like this. So these and the different symbols represent different tree species. So Ponderosa pine is green, pinon is the orange, juniper is the green triangles, and when they die, they change to a different color. And when they die, we also have mapped where the logs are on the landscape, laying on the ground precisely, and those ponderosas will be mapped as green and pinon as orange. We don't know when the log hit the ground in the past. We're showing what the map position of it is today. So an important point here is that you see in 1600, there are essentially no trees on this landscape. And this, we believe actually in the big archaeological site of Frijolito, which was occupied until the mid-1500s, a 100-room pueblo was sitting right here, just adjoining this. They left for reasons of their own. It wasn't related to Hispanic settlement of the area, because they were already off these mesas at that point. But they had abandoned this part of the world just before this. And we actually believe that we have the demographic history of tree recolonization of this site after it had essentially been deforested. One of the leading hypotheses about why the Puebloan people left these mesa tops was that after 300 years of intensive occupation, they had deforested it. And so anyway, we have some evidence of that. These trees can live quite a bit longer than 400 years. In Mesa Verde, you find, or you did until all the recent fires, 600 or even 800-year-old piñons, and the Utah juniper there is datable, that you can date back, that look like they colonized after the Puebloans left circa 1280. We don't have anything anywhere near that old in our woodlands. And we believe that part of that is because the occupation and the subsequent abandonment was several hundred years later in this landscape. So we're toggling through, so this is now 1650, and what you're seeing is Ponderosa Pine establishing at this point. We're in the Little Ice Age, and these conditions were favorable for Ponderosa Pine probably to push a little bit farther down slope than is comfortable for him today. You see down there's a little rocky area at the bottom and a little spot up here. These are rocky spots on the landscape that had piñon and juniper establishment. Those are the first places. But the heart of this watershed was actually Ponderosa Pine forest. So here's 1750, 1800. So you see this pattern of the whole middle, mostly the whole upper part is Ponderosa Pine. And then 1850, and probably the junipers, we may have, again, we can't precisely date them. I think we're giving them a few too many years because I think they should track with the piñon. But now watch what happens. At this point is when the surface fire patterns of the sort you heard from Chris Rose last week stopped. And the piñon and the juniper are very sensitive to fire. So during the surface fire period, they were growing in these rocky places that were not supporting the surface fire. But in the middle of that watershed, no. But by 1900, they're starting to show up all over. By 1940, you see that there are piñons and junipers established widely through the whole watershed. There are still some live Ponderosa pine. By 1960, at the end of the 1950s drought, though, every Ponderosa pine in that watershed had died. So they are present only as logs. So this system that for a couple centuries was Ponderosa pine dominated had become dominated subsequently by piñon and juniper, who are now the dominants by 1960s. Jumping ahead another 40 years to 2001, which is picked for a particular reason, you see that the density, I'll just toggle back and forth between 1960 and 2001, just continued to go up. There was a wet period from the late 70s through 95. Subsequent to that, we started to go in drought, and in 2002, 2002 was the worst year for tree growth in the last 1,000 years in the Southwest, definitively by a region-wide tree growth assessment that's been done. And in 2002 and 2003, all of these piñon that used to be alive, basically every mature piñon died. Again, just to toggle back, what happened? That actually, if I mapped it in 2003, it would have looked the same in terms of that. They died literally within a 6-month window. A big transformation in the landscape. So today, the landscape looks like this. And yet we know that for a couple of centuries, much of that watershed actually looked something like this. An open stand of Ponderosa pine with enough grass cover to support surface fires. because there were fire scars in that record on many of the trees. So again, and people had a huge role in this history because it seems that the woody plants had to start from ground zero there in the late 1500s. What do we know about the density, about human occupation of the landscape? So to push this back a little farther. So regional scale patterns of population density in the Southwest, and by the way, we're here. So this is the Jemez. Bandelier sits right about there in this spot. So in the north, so this was just after, right, the evacuation of the Four Corners by the farming peoples. Yeah, Bandelier's there. Zeroing into we'll now go to the Archaeological Survey data from this part of the world, and all of this has been surveyed. So here is that 1 hectare watershed of Friolito that we call the Friolito watershed. And we're going to look at the archaeological evidence through time around that. So here is 2,000 years ago, a little bit of archaic lithic scatter stuff. Here is 1200, 80, 1200, before the influx of immigrants from the Four Corners. And again, you see the different sizes of the symbols represent the size classes of the different and types of features, cultural features. So by 1350, originally the people who lived in these scattered, smaller room blocks, structures, probably family, extended families. And then the aggregation occurred through the 1400s and into the 1500s. So these red squares are communal pueblos of 1 to several hundred rooms. So here's Friolito, the pueblo which we named the watershed after. So you can see, though, that this landscape had a lot of people in it for several hundred years, and estimates of how much of that landscape on the uplands they would have had to utilize for farming to support the populations that were estimated. What is now the Bandelier Wilderness is estimated to have had between 1,500 and 3,500 people living in it, essentially continuously from the late 1200s through the mid-1500s. So for on the order of 300 years, there were 1 to several thousand people living in the untrammeled, pristine Bandelier Wilderness. Yeah, I think we can skip that. That's just a little detail. Similar, well, here's Pinon. So this is, if you look at the decade in which the tree's established, you see there's this tidal wave of Pinon establishment after the surface fires stop in this time period. Okay, I forgot to show you the fire scars when I showed the timelines of the individual old woody trees. Yeah, the point of this is simply, this is from Henry Gracino Meyer's dissertation work at El Malpais National Monument, actually, where they have a longer than 2,000-year tree ring chronology from 4 different species, actually. It's probably still the single best precip climate reconstruction in the region. And what you see in all time scales is that drought is a natural feature of this landscape. That precipitation is variable on all time scales, essentially, is the only point I would make here. You see the 50s drought. The 50s drought is shown here. The current drought, because Henry's work stopped right when the 50s, when the current drought kicked in. But we are now in a drought that's similar in magnitude to what happened in the 1950s. And indeed, these are some of the trees that have died recently. Actually, these are remnant Ponderosa pine from the 50s drought on the ground. These are Pinon that died in 02, 03, and these are similarly Ponderosa pine that died in 03 as well, up on that mesa top surface. Basically, the bottom margin of the Ponderosa pine zone has been dying back through these drought episodes in the 20th century. This was from a paper that actually with a colleague we published in 98 in the proceedings of the National Academy of Sciences, because what was the big story? It was about a rapid upslope shift of the boundary of the Ponderosa Pine Zone. The bottom edge of the Ponderosa Pine Zone retreated upslope by 1.5 miles in less than 5 years during the 50s drought. Basically, the bottom fringe of Ponderosa Pine died back. And during the current ongoing drought, Ponderosa Pine, the bottom portion of that distribution has continued to retreat upslope. And it's another whole topic. I don't go into, I mean, most of my work in the last 15 years really has been climate change related, supported by a USGS climate change set of projects. But that's projected to continue. But this was interesting because this remains till today the largest rapid shift of an ecotone, of a vegetation boundary, that's been documented in the literature. Here's 2002. Here's the sort of drought, instrumental observations of drought in the U.S. And you can see centered on the four corners, and Bandelier is there. And this is what it did to those trees. So I showed it to you in this kind of maybe obtuse, maybe I should have started it this way, but form showing how the piñons died. Well, this is what it looks like when you're standing there in 2002, 2003. So here's fall 2002. This is part of Bandelier. And all of the orange canopies you see are, these trees are already dead. These are the piñon, the small pine trees. The next slide is 18 months later after the needles have dropped. So you see the gray skeletons of the piñon. The trees that are still green are the junipers that survived on this site, that drought. So again, just to toggle that. This is a pretty extraordinary, big, fast change in a system. And for reasons that, again, I won't talk about much here, but because I'm focusing on this older history for this talk and the erosion and what we did about it. But suffice it to say that the Jemez in general and Bandelier in particular have been, well, we have been on kind of the leading edge of seeing how big fast changes can occur on landscapes with climate change type drought. And so this has become a bit of a poster child landscape for research by a number of folks about how these landscapes, how they get these nonlinear tipping points that can really drive big, fast ecological and hydrological change.
At recomputing the bottom 25% of 16 and the bottom 25%.
We're hearing somebody in the background. I don't know if that. So here is actually the fire scar chronology from the Freolita watershed.
Craig, just a minute.
Yeah.
Excuse me. If you're talking, carrying on another conversation, could you please mute your phone? Thank you. Go ahead, Craig.
Yeah. So this is a fire scar. You probably saw a bunch of these from Chris Rose last week. But so again, timelines of individual tree samples, calendar years on the bottom, and each vertical tick mark in this case represents a fire scar recorded in the tree rings. You'll see they tend to be synchronized. Here, this is 1842, and almost every tree up there recorded fire. So we know that there was enough herbaceous ground cover to be able to support spreading fires into at least the mid-1800s. And then you see it ceases, and there has been no fire on this site since I think 1858, looks like was the last significant year on this site, which is early. Here you can see it spatially. So here's a scale. This is 600 meters, the spatial scale here. So this is on an air photo. Here, the yellow outline is the Freolita watershed. The red trees are trees that showed a fire scar, sampled trees that had a fire scar dating to 1842. The green ones are trees that were sampled at the same time that potentially could have recorded that and did not. So what you see is that this mesa, that fire spread widely across this woodland mesa top. And indeed, 1842 was a watershed-wide fire year in which this is the canyon bottom. here. The headquarters of the park is actually right here for those of you that know it. But 1842, there was fire across from these elevations all the way up to the Caldera rim, 13 miles up gradient. So fire was very widespread in that period, which requires some kind of surface fuels to carry it. But this is what that world looks like today. It's inconceivable that you could sustain surface fire. So this is one strong line of evidence about just the magnitude of ecosystem change in this site. What drove this? Because the fires actually stopped several decades before active fire suppression became a policy. Fire suppression did not become a policy until subsequent to 1910. Right after 1910, there was a very bad fire year. Prior to that, there was debate about whether fire was a good or a bad thing in western forests. What happened prior to that, though, in the year 1880, literally that year, railroads extended down out of Colorado into New Mexico. They reached Santa Fe and Albuquerque and the foot of the Jemez in the year 1880. And by the 1890 census, there were 5 million sheep and 2.5 million cattle and hundreds of thousands of horses and burros and whatnot, grazing in open range condition, meaning there were no permits on the extensive public lands, and literally they ate the grassy fuels that sustained the surface fires. And so fires collapsed, these surface fire patterns collapsed all across the whole region in the 1880s and 1890s. And by 1900, these surface fire patterns no longer existed in this region, even though we have many hundred years of record. The Haman, actually, we've done many fire history studies in the higher elevation forests. It's perhaps the best sampled landscape on the planet, intensity-wise. So anyway, this story is quite robust. That livestock grazing, when you remove that herbaceous cover, it also has major hydrological effects. In this part of the world, the sheet erosion that we've been observing for the last number of decades here appears to have been also triggered by that same episode of landscape-wide livestock grazing, which, by the way, coincided with another one of these severe drought episodes that was centered on 1900. So basically, just as the livestock numbers peaked in the late 1800s, there was one of these multi-year drought episodes, decadal scale drought, that continued into the very earliest 1900s. Animals were starving across the landscape, and numerous documentation of just how bad the range conditions had gotten. And basically, if you decrease the surface cover of plants and measure how much erosion occurs, you cross literally a threshold where at some point, instead of the vegetation-covered patches being connected, if you pull out a few too many grass plants, the bare patches coalesce. It's called a percolating network. But basically, the concept's pretty simple. Once the bare soil starts to connect, when raindrops fall during our intense summer thunderstorm monsoon period, the water aggregates, and if it doesn't run into anything to impede it and cause it to infiltrate, it just gathers energy as it aggregates down the slope on these connected bare patches. That appears to have happened broadly across these landscapes. And so the overgrazing drove these two huge changes. It stopped the surface fires, which were regulating the vegetation, and it also triggered these episodes of erosion at a landscape scale. Well, this is the erosion and runoff monitoring infrastructure that we had for almost 20 years in that watershed. And I won't go into the details of it except to say we had 2 flumes down at the mouth. We had a remote weather station. We had sediment traps at multiple spatial scales. We were measuring vegetation cover. We measured surface erosion in multiple ways through changes in microtopography. We did an immense amount of work on this watershed. This was like the dominant thing in our summer season. Every single precip event, we'd go out and remeasure. We would collect from the sediment traps at 3 different scales. 1 square meter, 10th hectare, and the whole watershed. We dig out those sediment traps and measure it. And the runoff was also collected. These are those 3 spatial scales, the 1 square meter, the 10th hectare. Uh-oh. What did I do, Karen?
What's wrong?
On my screen, it's not full screen anymore. Here we go.
You just touched something.
Yeah, I did. So there we go. Sorry.
Are you back?
I'm glad. Yeah, it's back. I'm back there. So anyway, point is only just this one piece, and this is the same little chunk of hill slope where some of these dead pieces of wood like this, we sampled 6 times trying to get the best death date and the best germination date that we could. We have soil carbon measurements all across this watershed. We measured wind erosion in this watershed here's one of the wind samplers. The only point I'm trying to make, this one little 2.5 acre piece of hill slope, we have tried to understand its current pattern and process and historically as best we could, using as many different methods and lines of evidence as we could. And the bottom line we were seeing is just these soils are not that deep here. We're talking like 15, 18 inches in most places. And we're losing on the order of a centimeter a decade in the 90s when we had these measurements. This is just some of the data. We don't need to. A lot of variability between years, reflecting the variability in precip. I won't talk about this other than to say that I'll just foreshadow to you that when you standardize the erosion rate as a function of both the magnitude of each precip event, but also the intensity, by which I mean the amount of the precip that arrived in either a 15-minute or a 30-minute window. Because that intensity, if you get 1 inch over a 10-hour period, that's way different than if you get 1 inch in 5 minutes. And our storms tend to be closer to, the 1 inch in 20-minute kind of variety. Those are the ones that do the work. But anyway, this is standardized for that precip intensity of an event. And what it showed is that actually don't worry about the axes. This is time from the beginning of the study to the end. But notice here that in the 2000s, the actual erosion rate started to go down. This was after the pinon trees died in 02, 03. And particularly when they started to fall on the ground, which was surprisingly quickly, within 18 months. And I'll show you why we think that. Also, we know that this erosion hasn't been going on for you couldn't have these kind of erosion rates for hundreds, much less thousands of years, or this would have been stripped. This would have been just a bare rocky hill slope already. And another line of evidence is that we literally have watched the channel network emerge before our eyes. So here was the channel network early in the study in 96. There was the channel network 7 years later. We're literally watching these channels with individual rainfall events emerge on the landscape, which is an indication that it's a new phenomenon to have that happening. There it is a couple years even after that, further proliferation. We also where the big Ponderosa pine trees from the 1950s drought had died and fallen, there are now in places created these log sediment dams. And we figured that, once that log fell and started to accumulate sediment upslope, it buried the soil profile that existed at the time the log started to do that. So we had, I think, like 4 or 5 places where we trenched above and below the log to look at the soil profile, and you indeed see that below the log that the topsoil had been much more removed than above the soil. Again, reflecting that these high rates of erosion we were measuring are relatively recent phenomenons. This is not something that's been going on for a super long time. And then here's what this landscape looked like. So again, these trees died in 2002, 2003. Here's what it looked like in 2000. Or the standard response was you got this herbaceous response in the litter mound right underneath the tree. 2005, we finally got a wetter winter. The drought had persisted through 4. 2005 was near normal winter, and we got pretty good herbaceous response across large areas that previously had been bare with less tree competition. And then the trees are already falling on the ground. And what these things did is they interrupted, again, the continuity of the bare soil. So we started to see a decline in the erosion rate. And, yeah, these are just measurements of that. Here was the decline in the percent of bare soil and the corresponding increase in litter of various sorts. So I think we're going to see logs emerge in this. Yeah, these are the brown are the logs. These are the logs that had died pre-1993 that were on the landscape, mostly in the 1950s. These are the channel networks as of 2006. And those are, I believe, the pinon logs as of 2006. There's more now. I won't go into this. That's some detail and connectivity. But this is an important summary slide to just visually think about this. So in the since 1600, we've gone through a landscape that had no trees, to a landscape that then developed an open Ponderosa Pine system with surface fire for 200 plus years, that then through land use change, the surface fires stop and it becomes a highly erosive landscape. The Ponderosa Pine that dominated the middle all died in the 50s drought and did not regenerate. And so we were left with pinon and juniper, that then all the pinon died in the early 2000s, and we were left with just juniper, and now we're starting to see recovery to more herbaceous conditions again in some places. Meanwhile, at the same time, starting in the late 80s, once we determined that this erosion was a big deal, B, recent enough to be tied to Euro-American settlement patterns and this overgrazing history and the changes that wrought, we started to see, well, is there anything we can do about it? So we worked, this is a master's student, Geneva Chong, who we supported in 92 to do this work, testing multiple kinds of treatments. Basically, we were seeing what could you do, and we tested seeding, mulching, raking in the seed. We girdled trees to simulate herbicides, maybe because there might have been just too much woody competition. That's one of the issues. Mulching, here you see the straw. We were testing multiple things. That morphed into a larger study once we had some initial results where we worked in 2 adjoining 100-acre watersheds, what we called this pair watershed experiment. This was a PhD project for a man named Richard Gatewood. The vegetation specialist at Bandelier, Brian Jacobs, was central to all of this work. Brian's actually retiring at the end of the month. And the big summary write-up of this has just been accepted in, I forget what journal. But anyway, Brian has summarized all this. Richard actually didn't get as much of it published as we would have liked. So this was sort of Brian's big summary project. Anyway, this is much of the various kinds of measurements of erosion and vegetation cover. And what we did, these 2 adjoining watersheds, there was the control watershed on the west, and then this second watershed was treated in 1997 after 1 year of baseline studies. The basic treatment that we had converged on was to go in and cut smaller pinons and originally, and mostly junipers, and lop and scatter the branches across the bare inner spaces between the trees. When we tested that method, here is the boundary. This is a helicopter view. This is the control watershed, and this is the treatment watershed. And this is literally, let's see, it looks like it was June. So this would have been like 3 months post-treatment, okay? And there it is looking down on it, on the boundary between the watershed. They're standing on that boundary. This is 2 growing seasons post-treatment. It's like walking from the moon to a meadow, walking across that boundary. Even yet today, the treatment effect, you see the dead branches, and you see the immense herbaceous response that occurred from that changing. And what it basically does is, by putting those branches down, they act as zillions of little check dams. They create the surface roughness that the water, instead of aggregating and running off, leaving a dry, easily drying soil behind and eroding, the water infiltrates when it hits the surface roughness and now the new live vegetation, which leaves more plant available water because more of the water is retained on site. And also then you start getting more shading, you get changes in the microenvironment at the soil surface where a seed, a little tiny seed, you got to think, what is the environment that experiences? And you basically change the microenvironment. And so literally with this simple treatment, no exotic material, in the end we didn't seed, our experimentation determined the more conservative treatment of just modifying with this slash the dynamics of water on the system, take systems that look like this into systems that look like that within 2 to 3 growing seasons. All right. However, at the same time that we did this work, we were right at the end of the wet period, and we were starting to go into that dry period. The year after treatment of this was, we caught a nice wet year of 97. Okay. Since that, we've been in drought. Oh yeah, here's zooming in at here's this nice little quadrat is like an award frame for the scale. So, but basically it ramped up. Existing plants got larger and many new plants established. And this is what 6 years after treatment the treated watershed looked like. I mean, it was astounding. We put it on a public trail because we were pretty confident it would respond this way by that point. And it made it an easy place to interpret, to bring people in. We also supported a master's project that looked at 6 pairs of basins, 10th hectare each, where we put these little silt fence dams to measure the sediment yield in the treated and the untreated. And what you find is after treatment, sediment accumulation dropped 100-fold at that spatial scale. It works. The diversity and productivity of every biotic group we looked at, from butterflies to grasses, birds, surface-dwelling arthropods, those all increased in both diversity and abundance. The systems, not surprising, the base of the food web, the herbaceous part of the system, greatly increased in productivity. And the whole process, we were close, the Park Service was close to ready to go, about 2000 to do this. And then the Cerro Grande fire happened, and that truncated the leadership of the park for some time. And it was sort of, it was a success on the part of some of us who survived that transition to just keep this project alive and on the burner of the incoming superintendents, because for a while, well, in 10 years, the park had 8 superintendents in the period from 2000 to 2010. So it was, you all can imagine what that would be like a little bit. But anyway, by about 2005, it was back on the radar screen. There was a multi-year environmental impact statement done to consider treating up to 5,000 acres in Bandelier. And most of that is in congressionally designated wilderness, again, to remind you. So, and in August, that EIS went through, and we began the full-scale treatments. Just a comment about that, I would say that, well, this was and remains a quite unprecedented project, because the minimum tool that was determined necessary to implement this project was a chainsaw. So this cutting would involve cutting small juniper stems and lopping them into pieces and then hand scattering them in congressionally designated wilderness in a national park unit. And it was about 4,800 acres treated, most of that in wilderness. Here you see that veg map of the park and its immediate boundary adjoining areas. This will show the, well, sorry, to back up again. So again, just to remind you, these orange areas are the mesa top woodlands at the lower elevation mesa tops where the treatments are. That's where the issue was. That's where this project was about. So here you see the years. I'll just toggle through where the treatments occurred. So this was that treatment watershed. That's 100 acres right there. That was done in 97. And then a decade later, we started the actual treatments for the project. So there's 08. Actually, 09 happened. And these all happened too. These are old slides, sorry. But I recycled part of an old show. But in the end, it was close to 5,000 acres were treated, and it was done as of September 2010. The project was implemented. When you go into these areas, not every acre is treated within this. If you zoomed in, there would be another whole mosaic. Areas that where the soils were too far gone, where the soils were skeletal, where they were, too much rock exposed. It was too late. Pumice soils were not treated, with a few exceptions. There's two different substrates. These old alpha sols of the tuff that were these 100,000-year-old soils, and then there's a really porous, coarse textured soil layer of airfall pumice. The erosion was not a big issue in those. Those already have such high infiltration rates. A whole array of monitoring in there to determine the success of these things. So this work is ongoing and continued. I mean, it doesn't get done every year, but we have baseline in all these places. There have been some remeasurements, enough to have some indication of the success, and quite a few archaeological sites that have been monitored within there as well. So from pre and post treatment, I mean, there's many more ARC sites than this within the sites, within the treatment zones, but these are the ones where there's been formal monitoring of the change in erosion on the cultural resource sites. Again, so nearing the end here, just as a reminder, this is the Bandelier Wilderness boundary. There are some areas of woodland here outside that boundary, and then in the outlying unit, the Sankawi unit, that's not wilderness. But it was that combination. I'm quite confident this project would not have, well, at least it's much less likely it would have been improved, and that there would have been sort of the energy to see it through if it was just a natural resource issue, if it was just about accelerated erosion. But the fact that it was both a cultural and natural resource issue, and that it was impacting the cultural resources for which the monument was designated. And this is actually within the Wilderness Act. This was sort of the tack that supports the intervention in an untrammeled wilderness in an area. And we were not trying to restore a particular structure of vegetation. We were trying to so it's not like we were trying to, in other words, we're not trying to get it to say 32 stems per acre of a certain size class. What we were trying to restore is the process, the natural processes that had been interrupted, the balance between surface cover and runoff and erosion processes, and the feedbacks to the vegetation that come from that, and ultimately the feedbacks with surface fire, again, in the system. It was done with some discomfort on our part. Brian Jacobs and I in particular were kind of the two drivers of this thing, and yeah, we're fully aware we've left fingerprints, handprints at some level on that wilderness landscape. Juniper stumps, I mean, we're only cutting small stems out there, but they don't decay rapidly at all. I mean, they're quite persistent. People use them as fence posts for that reason. And there were a number of responses, uncertainties, excuse me, in terms of how the system will respond. We know, you know, it was framed in a restoration framework. We called it an ecological restoration project. You can't go back to where it was. The best part of those soils had already been lost from those affected areas. So the system, just from that alone, couldn't go back. And of course, climatically, we're moving into no analog terrain fairly rapidly. We're pretty much there in the Southwest in recent years. We may get a reprieve, by the way, in the Southwest, because sometime in the next decade, the Pacific should slosh back to the cool phase, to the warm phase, in which El Nino conditions would be more prevalent again. So we may actually get a wetter and thus a bit cooler window again for a bit. But by mid-century, it'll go back again. And at that point, it'll be pretty difficult, probably for a lot of the current vegetation in this landscape. We've seen a foreshadowing of what that can look like. If it's another degree C or 2 warmer, by the next big drought episode, we'll see another round of this. But in the meantime, there will be, I'm thinking there's going to be a good window to do treatments of this sort and analogous kinds of things in the higher forest types, the kind of things that it sounds like Chris talked about last week. But anyway, as we were, it's amazing, the most negative, well, there were only 2. You know, we went through an EIS process with public meetings, multiple public meetings in the cities of Los Alamos and Santa Fe. The most 2 negative comments received on this project were from Brian Jacobs' daughter, a grade school student, who sent him a drawing and said, please save the trees, Dad. And from Park Service regional wilderness manager who just philosophically didn't like the idea of intervention, deliberate intervention in a wilderness area, even though our basis for that is that the system was far from natural. It had been intervened in deliberately and inadvertently many times previous, and thus it was out of whack in a sense. We brought in the Bandelier Wilderness was congressionally designated in 1976. We put that paired watershed study in a place where it would be easily accessible. It was in the wilderness, in the edge of the wilderness. And we brought the 3 godparents of the Bandelier Wilderness in, actually on the same field trip. And we spent the day, along with others. We had the Park Service Wilderness Steering Committee in there on the ground, at least once, maybe twice, given the delay in the project. And we go through sort of our best understanding of how this landscape had changed through time, what our evidence for it was, and some of these uncertainties. I mean, we were very clear about what we did and didn't know, or at least our best understanding of it. And at the end, we would ask people, and then you go out and look at the treatment, and it's such a dramatic treatment effect. And the sort of the end question was, what would you do if it was your responsibility to manage this? With a Park Service mission or a mandate to maintain these resources, quote, unimpaired. And how to best balance those things. And we had that conversation up front before the EIS process. We brought in the people most likely to object, the Wilderness Society. We brought in various wilderness people, the New Mexico Wilderness Alliance and the Wilderness Society, and various other environmental groups. We brought in many of the locals who loved and love still Bandelier and its wilderness. And in the end, people thought we were taking the responsible course of action. And so, But nonetheless, there are these uncertainties, and thus the monitoring should continue. This is just some of the new work by the Southern Colorado Plateau I&M program, and I've put in a new set of plots in the last half dozen years that are part of it. The last slide I have is just a little bit of a shout out, actually, to the crew members, and here actually is Rory Gauthier, who just retired last summer, sort of archaeologist extraordinaire. He grew up in this landscape, and so Rory was great. And so directly overseeing the treatment to make sure there weren't impacts from treatment on the arc sites that we didn't want. Although we did treat over most of the arc sites in the sense of cutting out trees we didn't want that would not have been there except for the absence of fire, and spreading some slash around particularly the margins of the sites. But these crews, I wanted to just mention, these were it was contracted out. This is a guy named Noel Aquino from the state of Oaxaca in southern Mexico. And all the crew members were mostly probably illiterate. Certainly I speak Spanish well enough to really enjoy interacting with them out there. Noel so understood the prescription of what we were trying to achieve. He moved faster than we could. Anyway, I just wanted to recognize just how hard and how fast and how well the quality of the work that they did. It wouldn't have happened without that. And I think that's enough. I think I'll stop. So, one more thing I'll just say is that, and I didn't think about that till it was just a little too late today, but so that was through 2010, this treatment was implemented. We've been in severe drought since 2000 onward. With literally since 2000, there have only been 3 years where we've had close to average long-term mean winter precip. The 11, 12, and 13 have all been very dry. 14, we've been close to average again. But in 2011, there was an extraordinary fire, the Las Conchas fire, that burned 156,000 acres in the landscape, including 2/3 of Bandelier's area. And it did burn over, I think it's 23% of the treated area. So there's another variable in the mix, which is, because the intention has been to keep fire out of the treatment areas for at least a decade to allow the perennial herbaceous vegetation to increase enough to, we don't want to burn up the woody slash too soon, because that's really sort of a form of biological capital. We only get one shot at that on these fairly low productivity sites. But anyway, on a little over 20% of the treated areas, it did burn. So we've been monitoring the effects of that as well. And, well, the story will continue. We're clearly in this era of the Anthropocene. We're on a trajectory. We're not going back to that historic range of variability anytime soon, it doesn't look like, if the climate models are at all right. And, but anyway, let me stop there, and if people have questions or whatever, glad to discuss further.
Oh, Craig, thanks for a great talk. Do people have questions and comments?
Hey, Craig, this is Jim Kendrick. I'm up in the Northeast region now, but I was out at El Malpais during the time frame that you're talking about there, and you've done a remarkable study, and the team at Bandelier has done a fantastic job there. It's just remarkable to see. I remember traveling back to Bandelier during one of those years right after around the Pinion die-off, and it was so dramatic it was difficult to recognize the landscape from what I had known in the past, and now to see it graphically and with all the data you have is just tremendous. Great job.
Thank you.
Mm-hmm.
Again, I would. There are a lot of players involved, but yeah, I mean.
Yeah.
So, but thanks.
Yeah, I'd gone up with Rory to see some of these areas, and we kind of did something writ small and certainly not as scientifically rigorous out in some portions of El Malpais off the lava that that were pretty successful too. So yeah, it was good.
Good.
Hi, Craig. This is.
Sorry, go ahead.
Hi, Craig. This is Chris Rose.
Hey, Chris.
How are you?
Good.
I wanted to ask you about the conditions before the 17th century germination and regrowth in Friolitos. How much, particularly in light of the absence of major erosion after the ancestral Pueblo occupation, do you think that the human use and deforestation and agricultural use of that landscape interfaced with the 16th century mega droughts? Certainly, especially, I guess, contrasted with the grazing impacts and kind of what those two different, fairly intensive use scenarios meant for the erosion and hydrological history.
Yeah, well, I mean, it gets a bit speculative. Obviously, I mean, we don't have, if you want to come out and investigate on small basins, Chris, we would love it. To try to get some, see what kind of resolution might be attainable about what might have been happening in terms of like sediment dynamics in little basins or things there. The way I sort of, the way I envision what happened there in the 1500s is that the ancestral Puebloan folks had the woody component of that system was squeezed pretty low by that point, by the mid 1500s. I don't know about exhaustion of the soils. I mean, Bob Powers is still trying to sort some of that out. Trying to finish off a dissertation. I don't think he's quite finished it yet. And, the way I think that what was holding the soils together was not trees, right? It was the herbaceous cover, the things that were providing the fuel connectivity for surface fires, which admittedly were lower frequency down in that zone than they were just a little bit further up Mesa when you get into the Ponderosa Pine, more into the heart of the Ponderosa Pine zone. The fire frequencies are substantially greater in the tree ring record. So we're getting down to the zone where fuels probably were limiting, and that's climate mediated in part, of course, down there. But the way they conducted agriculture with digging sticks, I don't see them, I don't know, tell me if I'm thinking wrong about this, but in terms of interrupting, I don't see them creating big swaths of bare soil, connected bare soil, in a way that would have promoted a big pulse of erosion. I mean, I'm sure there were localized patches of it, but that's sort of my sense. And then the 1580s mega drought there, the late 50s, the sort of thought around here is that was kind of the last straw that probably pushed people off. You don't see tree ring cutting dates in the few that we have from the Pajarito Plateau, from the Bandelier part of the world. There's very few after 1550. There's a couple, but there's nothing after 1580. So that seemed to have been kind of the last thing, the last sort of straw in it. And then of course the Spanish arrive and missionize and colonize that part of the world right then in 1598, and so the whole sequence is altered after that.
Yeah.
So was there something else? I'm not quite sure what you were fishing for.
I've got a lot on my mind. I don't want to take up everybody else's time. Maybe you and I could chat again at some point.
Yeah, be pleased, of course. So.
Thanks for a great talk, too.
Yeah, thank you.
Hey, Craig, this is Helen Fairley. And I had a question. I think it might have been related to Chris's, but you'd mentioned early on, and actually this is the main question, but I'm curious about it, that there was speculation that it was deforestation that had sort of reset the landscape in the 1600s.
Yeah.
But it would sound to me like what you just said a moment ago suggests that there really isn't direct evidence for that. That might be more speculation than actually based on evidence for extensive cutting of beams or whatever during that period. And that
that's true. For sure that's true. And the other thing, and I didn't say that, but I mean the 1580s, you know, that's been kind of the index mega drought for the last millennium. I mean the late 1200s, the 1280s, and the 1580s are sort of thought to have been the two worst droughts regionally, more or less, until perhaps the one we're in now, which is being amplified in severity from a plant perspective by the warmer temperatures. But in any case, the 1580s drought was severe enough, almost certainly, to have killed lots of trees as well in systems. And there's some, again, indirect evidence of that. When you look at tree, Peter Brown and Tom Swetnam, 20-some years ago, just looked at all the tree ring samples from the Southwest region that were in the tree ring lab archives at that time in their databases, and looked at how old trees were. And what you find is you can find lots of trees, many trees 400 years old. There's lots of trees that old in the Southwest, pushing back right to that late 1500s drought window. And then the number of trees that people find to sample drops precipitously, and then there's a really long tail that goes back for hundreds of years. So these trees can live many hundreds of years more than 400 years old, but it looks like a lot of things didn't get through the late 1500s drought. So, I mean, like a lot of these things, it could have been interactive. But if you think about how much wood people would have needed to use, I mean, again, high densities, high numbers of people for centuries doing swidden agriculture, probably using fire as a tool to clear the canopies. They're not growing. Their staple foods are all very light-loving. They need it to be open. They're all things you cook, corn, beans, and squash, so you need fuel wood. They're living in stone structures on mesa tops that are quite cold in the wintertime. I mean, it's so you're heating. It's actually hard to imagine how they could not have deforested those mesa tops.
Right.
Over that kind of a time period, and these trees don't grow that fast. And again, the age structure, and it's not just in that 1 hectare. We don't find old piñons anywhere on these mesa tops that go past that window. And again, there's some confounding effect there, I think, of that late 1500s mega drought. Maybe that took out, although it would, I mean, there should have been young trees that got through that would be 500 years old today. Whereas in Mesa Verde, you can find 600, 700-year-old piñon. You find piñons that established in the century after that landscape was abandoned. And in there is some better archaeological evidence, like changes in fuel wood found in hearths and things through time, indicating that fuel wood scarcity was emerging in that part of the world, in that up there in the Cortez and Mesa Verde kind of region. So, I mean, I don't know. I think but yeah, we don't have some, perfect smoking gun for that.
Can I ask one other real quick question? You mentioned that in follow-up to doing all this treatment, you have a sample of archaeological sites that are being monitored for erosion control.
Correct.
Can you just very, very briefly, because I know probably people have other questions, but one, either give me a sort of an overview of what's involved in that, or point me to where I might be able to find more information about the method.
Can you send me an email,
yep, and
I will send you the report that was completed recently.
Okay, that'd be great.
On that work. That would be by far the best way to do it.
All right. Thank you so much. I really appreciate it. Excellent talk. It was fascinating. Thank you.
Yep.
Craig, if you have a link or a URL for that report, I can also post it along with the webinar.
I don't have a URL for it, but I mean, I could send you a copy of the PDF and you could post it easy enough.
That's true. I can scan it and post it. So if you want to do that, I'd be happy to post it for you. Because I think that these are topics that are going to be, you know, of wide interest as we grapple with some of these same issues.
And are all these talks being recorded? Because this talk in particular, as I was listening to it, was thinking of about at least a couple dozen people who would really benefit from hearing it if they weren't on the call.
Yes. All of the talks that have been offered to the Archaeo Thursday webinars for the last 3 years have been recorded, and they're on our they're in 2 different places on Park Service website. I've sent out the links in the past, but I'll do it again. Helen, are you on this is Helen Farley, right?
Correct.
You're not on my mailing list.
Apparently not, but I sure wish I had been, and I would love to be on it in the future.
Okay, I'll add your name, and when I do that, you'll get the links to the previous webinars. This one will be up next week.
Excellent.
There's a small problem. I've started advertising these more widely, but at the moment they are not ADA compliant, so I haven't gotten very much assistance in, in sending out the word. But we've gotten, I think I have money to caption all of them, and once I do, then I'll be able to link them to all different kinds of announcements.
Wonderful.
And I think I'll be able to raise their visibility a bit more. But I'll send you the links to the previous ones, and this one is recorded, and it will be available next week.
Thank you so much. I really appreciate that.
Oh, you're welcome.